Page 33, number 5. A small 42 Newton sign is suspended from the end of a hinged rod, which is 2.4 meters long and uniform in shape, as shown in a diagram below. What tension force exists in the rope holding up both the rod and the sign? And the rope makes an angle of 60 degrees with the 36 Newton rod. That's its weight. Let's draw our free body diagram. Okay, I'll do it freehand right now. Freehand. Over exaggerate so that we can see what's going on. There's a pivot point at this end here. Let's draw the forces on it. Right in the middle is the force of the center of gravity. There's a sign on the end. Force of gravity of the sign. And there is, I'll change it to blue tension force in this direction. The force, and really it is a tension force. So we could have written down is that all the forces acting on it? No, there is one more force. And that force is what the hinge is pushing on the rod too. Because if you just took away the hinge all of a sudden and took away the wall, that would just swing right through the wall. There's a force that would want to push down. So there is going to be a force upward, most likely, but definitely away from the wall, this way. There's a force of the hinge pushing up on it. But believe me now, that doesn't matter to us. Why? Because we are going to we don't want to know what that is right now. So we're going to actively make our pivot point there. By putting the pivot point there, our torque formula says torque is force times distance times the sine of the angle between them. But if we put the pivot point at the force of the hinge, then the torque caused by that will be 0 because the radial arm is 0. So we ignore that force. When we do, the sum of the torques equals 0, and that means the torques clockwise is equal to the torques counterclockwise. The torques clockwise in this one are these, watch, that one and that one, the force of the sine. So let me just get rid of those big black arrows and write those down. That is the torque caused by the rod plus the torque caused by the sine has to equal the torque caused by the rope. So this is going to be force times distance times the sine of the theta plus force times distance times the sine of theta, and that has to equal force times the distance times the sine of theta. Every one of those torques has that formula. Now I'm going to kind of ruin our free body diagram and put some information in here to help me do this question. Okay? This distance here is 1.2 meters. This distance here is 2.4 meters. The center of gravity of the rod is 36 newtons. And the force of gravity of the sine is 42 newtons. And one other thing, this angle here is 60 degrees. Okay. Now we're ready to start filling in the data. The force of gravity of the rod, and that's the center of gravity, will be 36 newtons. The distance that it's operating at from the pivot point is 1.2 meters. And this is 90 degrees. They are at right angles. The rod is being held horizontally, so it is right angles. So this is just going to be 1. Plus, the force of gravity of the sine is 42 newtons. How far was that force operating away from the pivot point? Is 2.4 meters. And again, that is 1, because it is 90 degrees. What I'm talking about is that angle right there. What we have to calculate right now is that tension force. And we're going to multiply it by how far away it's operating, the D, which is 2.4 meters, times the sine of the angle between those two vectors. And that is 60 degrees. Pull up our calculator. 36 times 1.2. This is going to be 43.2 Newton meters plus 42 times 2.4. That's 100.8. So I'm just going to add those two together because we will need them. So I'll take that 100.8 plus the 43. And so this becomes 144 newtons meters. That's the total torque caused by the clockwise torques, which is the torque of the force of center of gravity of the rod, as well as the force of gravity of the sine, those two torques. And that has to equal T times 2.4 times the sine of 60, which is root 3 over 2. So T is going to equal 144. Divide that by 2.4, as well as dividing it by sine of 60. And we get a tension force in the rope (69.28